So I'd like to welcome you. I'm the Wales coordinator for the Continuous Cover Forestry Group, acting here in absence of our chair, Dr. Bill Mason. And I'm very pleased indeed to welcome Victoria Stokes, Dr. Victoria Stokes, to talk to us about underplanting and the experience at Clocaenog in particular. We're lucky. I know it's an unusual thing, the chair looks through the biography, and we've got a very useful person to talk to us here, Tor, who's got working in silviculture and wood properties group of forest research. So many of us interested in silviculture and wood properties, certainly. And you're the upland silviculture lead. You did, as I suspect quite a few of us did, studied at Bangor and did a master's in Bangor in ecology, and then a PhD in White Woods. Very, very keen to hear from you. I'll mention that I was a forest worker in Clocaenog Forest a long time ago. I brushed some of the trees in the experiment. And I think that's another thing that you work on, which is long-term experiments, which again, I think lots of us in this group would be really pleased to hear is going on. So I'll hand over to you, Tor, and invite people, if they've got questions, to put them in the chat, and I and Polly will seek to pick them up and do justice to them. We'll leave a reason, quite a good time for questions at the end and discussion, perhaps. Thank you. Over to you, Tor.
Great, thanks, Alec. Great. Okay, good. Right, well, thank you very much for the introduction, Alec, and thank you for the invitation to come and talk to the CCFG today. I'm going to be talking about underplanting of conifers in Britain, focusing on research experience from Clocaenog Forest in North Wales. So, firstly, there's been relatively little recent experience of underplanting in Britain. And it was commonly used in Britain prior to World War II, and was also used in the 1950s for restoring derelict woodland sites. But it's nowadays much more widely used in continental Europe and North American forestry. And some of you might be familiar with some of the classic German underplanting systems, like beech planted underneath Norway spruce, such as the one shown in the photo. But I'm sure this group is probably more aware than most that clearfelling and restocking is very much the default approach in Britain, and that when people do use CCF approaches, they usually use natural regeneration as the default way of restocking. But underplanting is a really valuable technique for increasing stand structural and species diversity. So firstly, just a little bit about what is underplanting. It can be quite hard to categorize, and that's partly because it's a very flexible technique and it can be used in different ways in a range of different silvicultural systems. Underplanting is not a silvicultural system in its own right, but it's a method of regenerating the stand, a method of regeneration. And one of the ways it can be used is in a simple shelterwood system. So that's where the trees are just underplanted below an existing overstorey. And then the overstorey is felled once the young trees are established. And it's a simple method of replacing one even age stand with another even age stand, but it does avoid the clearfell stage. So you could think of that type of underplanting as being restocking and then clearfelling, really. But alternatively, underplanting can also be a way to establish seedlings in much more complex CCF systems. And in those systems, the overstorey can be retained as a long-term component of the stand. So underplanting can help to increase irregularity in those systems in two ways. Firstly, it doesn't have to be done continuously throughout the whole stand. So you can do underplanting just in small patches. And you can also use mixed species as well to help increase the diversity of the stand. So it's a really very useful method in both CCF management and also transformation of even age stands towards a CCF system. One thing that I should say at this stage is that underplanting is quite distinct from group planting, which is carried out in canopy gaps. And the distinction really is that, as it says in the name, underplanting really needs to be done underneath the canopy of existing trees. So there's quite a few different situations where a manager might consider using underplanting. The first and probably most obvious of those is when the manager wants to change species or provenance, but without clear felling. And that's potentially quite a useful thing to do in climate change adaptation. Another suitable situation might be where a manager wants to introduce a second species into a stand to create a mixture, or perhaps to supplement natural regeneration where it's been unreliable or maybe a bit patchy through the stand. And another good point about underplanting is that it can give the manager control over the spacing of the seedlings and the distribution within the stand, potentially avoiding perhaps costly interventions like respacing later on. And finally, underplanting can be a way to give the next crop a kind of head start before the overstorey rotation age. So underplanting has really quite similar prerequisites to most of the CCF approaches. First and foremost, it's really important that there's a stable and well-thinned overstorey on the site, and that you've got good road and rack access, because the thinning operations are going to have to continue. It's like with all CCF systems, it's quite important that you have control over browsing mammals and also relatively low levels of weed competition. So it's probably not that suitable on very rich sites. But in the right situation, underplanting can give managers control over the species, the timing, and the distribution of seedlings on the site in a similar way to in a restocking scenario. But it actually also avoids the disadvantages of clear felling. So some of the key differences between open planting and underplanting are about the microclimate conditions. And a few years ago, we did a small 5-year project, which was looking at the effects of having an overstorey on the microclimate and also on seedling establishment. So what we did in that project was we planted Douglas fir on open planting sites and also in very close adjacent underplanting sites. And we used weather stations to record the microclimate conditions on both sites, and we also monitored seedling establishment. And what we found was that in many ways, the conditions underneath the canopy are actually more benign for seedling establishment. So under a canopy, the wind speeds were lower, it was milder and less frosty in winter, it was a bit cooler and wetter in summer, and extreme rainfall events had less of an impact. On the downside, of course, the light levels were considerably lower than on the open restock site. So we found really that the canopy does provide some protection from climatic extremes for young seedlings, but that seedling growth is usually slower due to the low light levels. So underplanting is really all about a trade-off between the provision of shelter versus the availability of light on the site. And that makes it particularly suitable for shade-tolerant climax species. So that's the species which have adapted to regenerate in a forest setting. And they tend to be species which can be relatively sensitive to exposure. So some of the silver firs fall into that category. But underplanting is less suitable for light-demanding pioneer species, which are adapted to regenerate out in open conditions, and they're often less sensitive to exposure. So one of the key questions when a manager is thinking about underplanting a species should be whether the benefit of the shelter will actually outweigh the lack of light for the species. At the moment, a lot of people are looking at diversification of Sitka spruce stands in particular, and we wanted to investigate whether underplanting could perhaps be used to do this. So some of the questions that we came up with were whether species can grow under a Sitka spruce overstory, and which species. The second question was, how do the growth and establishment rates of those species differ? So this comes back to the question about light versus shelter trade-offs for different species. And we also wanted to know, how do the different species respond when the canopy is removed? So I expect we've probably all seen naturally regenerated seedlings that have gone into check, where although they can survive for many years in low light conditions, they can be really very stunted and they can be unable to respond when the overstory is eventually removed. So we wanted to know whether that can happen to underplanted trees as well. Do they go into check? And then finally, we had one operational question, which was, can the overstory be removed without causing severe damage to the newly planted and establishing seedlings? Again, we know that natural regeneration needs really quite careful management during thinning operations. So we wanted to know how much harvesting damage there'll be to underplanted seedlings when the overstory is removed, and how can that actually be managed during the operations. So the experiment I'm going to talk about was based at Clocaenog Forest in North Wales. It's a 4,000 hectare upland spruce forest, which was planted around 1948 with a predominantly Sitka spruce overstory. The site had very regular thinning until 1999, but in 2001 it became one of the national CCF trial network sites, and a 42 hectare area within the forest was designated for research. So that research area has an iron pan soil, which is relatively poor in terms of nutrient regime and moist in terms of soil moisture regime. So the site overall has approximately 1,100 millimetres of rainfall a year, and it's at around 400 metres above sea level. So the DAMS score is also quite high at about 19. And the yield class of the Sitka spruce from the site is generally around 18. So it's a fairly productive site. So we have an ongoing collaboration and a memorandum of understanding with NRW and Bangor University, and that's enabled some really quite long-running research to take place in this area. So some of you may be familiar with the Clocaenog trial area, but for those that are not, it's important to sort of point out that it's a lake transformation to CCF site, and it has 4 different overstory treatments. The first one is this area down in the bottom left corner. That's an unthinned control, which hasn't been thinned since 1999. The 2 areas across the top here were managed as uniform shelter wood, and the underplanting trial is positioned in this location up here. This smaller area here was an irregular shelter wood, and then there's a group and strip shelter wood down in the southeast corner. So the underplanting experiment is in this 6 hectare area here. So previously it was uniform shelter wood, although you can see that this aerial photo was taken since the overstory was removed. So the experiment then, it was designed by Arne Pomeraning when he was at Bangor University, and it was established under the Tiffant Coed project with the then Forestry Commission Wales. It's been managed by Forest Research since around 2009. And the experiment trials 5 different conifer species, which have been underplanted under a Sitka spruce overstory. The species that we've trialled at the site then are Douglas fir, noble fir, European silver fir, Norway spruce, and Sitka spruce. For those that know Clocaenog, it might seem a little bit strange to be planting Sitka spruce because it has very dense natural regeneration across most of the site. But we wanted to include Sitka spruce as a control species to compare it against the other species. And we wanted to make sure that it had had the same establishment processes as the other species we were testing. So all of the species we were testing then in the experiment, they were thought to be site suitable and reasonably shade tolerant. And they were planted in 3 replicate blocks in a randomized design. So within each block, we had 50 by 50 meter plots of each species that were randomly allocated. You can see from the layout that actually the plots on the end of each block were half size. They were actually only 25 by 50 metres, and that was due to some supply issues with European silver fir in the first year. I'm going to just run through the site history and establishment fairly quickly. In June 2004, when the overstory was age 54, that's when the frame trees were selected, and the first crown thinning took place then down to a residual basal area of 25 metres squared per hectare. And that remained the target basal area throughout the period of the experiment. So, as we've already mentioned, there was a very dense natural regeneration of Sitka spruce across the site, and in October 2006, that was removed from the underplanting area using motor manual and harvester mounted flails. The experiment was then planted in March 2007. You can see that the ground conditions were really quite bare at the time following the flail operations, and the planting spacing was 2 by 2 metres, and the plots were not fenced. But then in June 2009, that was at the start of the third growing season after the underplanting took place, the overstory was crown thinned from 31 down to 25 metres squared per hectare. You can possibly just about make out the lines of underplanted trees in the foreground of the picture there. Then in June 2012, that's the start of the sixth growing season after underplanting, the overstory was crown thinned again from 30 down to 25 metres squared per hectare again. So following those two crown thinning operations, perhaps unsurprisingly, we had a large amount of new Sitka spruce regeneration on the site. So in this photo, you should be able to see the underplanted trees and then a very dense carpet of Sitka spruce regen coming through right across the whole experiment area. So in November 2014, we actually controlled that natural regeneration with a directed application of glyphosate. And again, that might seem a slightly strange thing to do operationally, but we didn't want it to interfere with the experiment, and we were trying to measure the response of the underplanted trees to the overstory environment. So it was quite important for us to remove any effect of competition from natural regeneration. Then finally, in October 2015, so that's the end of the 9th growing season after an underplanting, the basal area was back up to 30 metres squared per hectare again, and that's when the overstory was clear-felled. So that was done using a combination of motor manual and harvester felling and using forwarder extraction. So these are just a couple of photos after the overstory was removed. I'm afraid they're not very good quality photos, but hopefully it gives an idea of what sort of condition the site was in at the time. So regarding assessments then, we measured 50 trees per plot in the experiment, and that was done at the end of growing seasons 2, 4, 6, 8, 10, and then very recently the end of growing season 17. And at each assessment, we recorded the percentage survival, the height and the stem diameter at 5 centimetres above ground level for all of the assessment trees in the plot. We did also record leader lateral ratios, health and damage scores and lean scores, but those final three I'm not covering in this talk, but there is a paper which includes results of those, which I'll share at the end if anyone would like to see those. So moving on to some of the results then, this graph shows the percent survival on the left-hand axis, and then each of the different species is shown in a different colour. And then along the bottom axis, we've got the number of years since the underplanting was carried out. So the first thing to notice is that in years 2 to 8, before the final overstory removal took place, the survival of all of the species was generally pretty high. It was more than 80% for all species. And the analysis showed that there was no significant differences in survival between the species. Quite interestingly as well, there was no noticeable effect of the thinning operations, which were carried out in the third and the sixth growing season on survival. I'll talk about that a bit more later on. But I mean, this showed us that all of these species were able to survive under the canopy. And then the overstory was removed during the 9th growing season. And again, for most species, there was very little effect of the overstory removal on survival. For many of the species, it was just about 1% lower. However, for Douglas fir, there was actually quite a large drop in survival that went from 93% in year 8 down to 76% in year 10. And quite importantly, this didn't happen during the operations, but it occurred during the following growing season in the year after the overstory was removed. So this is a very similar graph, but it's looking at height rather than survival. So looking first at the first 2 assessments in years 2 and 4, at this stage, there were significant differences in height growth between the species. So Douglas fir and Sitka spruce were significantly taller than the noble fir and the Norway spruce. But by year 8, there were no significant differences in height anymore between the species. I haven't shown the error bars on these graphs just for clarity, really, but there's a lot of variation about the mean within each species. So the overall sort of message there really is that although noble fir and Norway spruce had very slow early height growth rates, they did catch up quite quickly. And then after the overstory removal, during the 9th growing season and the 10th growing season, all of the species were able to respond quite well, and they did continue to grow in the years following overstory removal. So just looking at diameter as well, European silver fir and Sitka spruce had the largest diameters, but there were no significant differences between species. And looking particularly at year 10, most of the species had really quite strong diameter growth following the overstory removal, which was in year 9. But interestingly, Douglas fir didn't seem to have particularly good diameter growth compared to the other species. There's not a lot of growth really between year 8 and year 10 for Douglas fir. So just 1 year after the overstory removal then, we weren't in too bad a position in terms of mean heights were between 80 and 140 centimetres, depending on species. The mean diameters were between 18 and 26 millimetres, and survival was over 80% for all species except Douglas fir. So the conclusions at that point were that all of the species tested can grow under a Sitka spruce overstory. And although some species were quite slow at first, they did catch up fairly quickly. And most of the species responded pretty well following overstory removal without showing any sign of being in check. But Douglas fir did have a weaker growth response, and its survival also fell quite a bit. So we wanted to know what happened next, and after a few years of not assessing the experiment, we carried out another measurement in March this year, which was 8 years after the overstory removal. So I've added just an extra bar onto these same graphs that we were looking at before, and that's for year 17, so 17 years after underplanting. And you can see that for most of the species, in terms of survival, there's been very minor reductions in survival over the past 7 years, generally 1 or 2%. But again, Douglas fir is the exception, and the survival has continued to fall between years 10 and 17. So it's now down at about 68%. Looking at height, so year 17 heights, there's very little difference in height between most of the species. So those that were very slow to start have clearly caught up with the others. They're all between 2.2 and 2.5 metres tall on average, but the exception now is Sitka spruce, which is generally about a metre taller than the other species. So that's really starting to get going now. And then looking finally at diameters for year 17, noble fir and European silver fir had actually the same diameter as Sitka spruce, which is probably quite a good trait to have on a relatively exposed sites like Clocaenog, increasing their stability. But again, the exception is really Douglas fir, which still has very small diameters and is lagging quite a long way behind the other species at year 17. So we wanted to find out really what happened to Douglas fir. Until the overstory was removed, it was among the tallest species on the site, and it had 93% survival. So if we hadn't actually removed the overstory, we would probably have counted that as a success. But interestingly, the problems with Douglas fir were not caused during the harvesting operations. It wasn't harvesting damage, but the deaths happened in the winter and spring following the overstory removal, so nearly a year later. We had an awful lot of very wet and windy weather that winter and really waterlogged soils, and quite a lot of socketing was seen on the site. So there were a lot of Douglas fir trees which were seen leaning at quite a big angle, or even lying on the ground like the one shown in the photo. And some of them had clearly been sort of battered around a lot by the wind. And the trees that were affected seemed to be particularly tall, but very spindly. And we started to wonder about their root development. So we had an undergraduate student at Bangor University called John Trimble, and John carried out his undergraduate project investigating this. So we were looking really to see whether there was a link between the above ground health of the underplanted Douglas fir and the rooting quality of those trees. So what John did was that he identified visually healthy and unhealthy Douglas fir based on their above ground appearance. And he then excavated trees and root systems from the buffer areas of those healthy and unhealthy trees. So it didn't affect our plots, but the trees had the same establishment treatment as the ones in our experiment. And John then used a scoring system to measure the kinking and circling of the roots of the trees. And he also measured a root orientation index to try and find out what the radial spread of the roots was. So the brief summary of the results really is that John did find that there were significant differences in root form and orientation, and that was related to the above ground plant health score. So the tree on the left is an example of a healthy Douglas fir, which had been given us a good root form score and a good orientation score. So you can see that the roots were going out in various radial directions from the stem. Whereas the tree on the right was an unhealthy tree based on its above ground characteristics. And it had very poor root form and very poor orientation. So the roots were only going out radially on one side of the tree. And you can perhaps also see that one of the roots there is actually curling around. It's got sort of kinked. So just to sort of briefly recap on the Douglas fir story, before the canopy removal, it was tall, it had high survival, but many of the trees were really very slender. Then in the year following the overstory removal, there was quite a dramatic decline in survival. Quite a lot of the trees were seen to be leaning over. And there was also limited height and diameter growth response. And that's also when John recorded the poor root form and orientation. So 8 years later, after the overstory removal, there'd been a further decline in survival. Although the heights of Douglas fir at that stage were equivalent to the other species, the diameter was still really lagging quite a long way behind. So we think that Douglas fir must have been really right at the limit of its shade tolerance in this experiment. And it seems to have been allocating all available resources towards height growth to try to capture as much of the available light as possible, and very limited investment in root growth or diameter growth. And what's really quite interesting is that 8 years after the overstory was removed and the trees had been growing in a high light environment, the Douglas fir still didn't seem to have recovered its vigour fully. So moving on now to some of the operational questions. The operations were all planned and managed by local NRW staff. And Clocaenog's been a CCF trial for over 20 years now, so there's quite a lot of local knowledge and experienced managers with a long involvement in CCF. And very fortunately, they were able to take their operational lessons learned in the wider trial area and apply those to our experiment site. So one of the key areas that the NRW team have highlighted to get right is the access. So right at the start of the CCF trial being installed, there were permanent racks put in with stone reinforcement where required. And they've also made good use of brash from outside the working area where they needed to protect some of the racks. And that's often been using roadside regeneration clearance. And the other area that they felt was particularly important was using appropriate felling methods. So they used harvester felling for the early crown thinnings, but then later on they switched to motor manual where necessary as the tree size increased. So within the actual underplanting experiment stand itself, before the underplanting was carried out, the site was zoned into underplanting areas and felling areas. So this little diagram sort of demonstrates how that was done, with the underplanting zones shown in red, and then the felling zones were shown in yellow, just slightly to each side of the extraction racks. So when the thinning operations and the final harvesting was carried out, the felling direction for each tree was actually marked onto the tree using a big paint arrow. The tree crown was then landed in the felling zone, and all of the processing was carried out in that yellow zone. So the trees were dragged into there and processed there, and timber was also stacked in the yellow zones. So that seemed to be a very effective way of protecting the underplanted seedlings. And we actually lost less than 1% of the seedlings at each intervention. So regarding the operational practicality, it did seem to be possible to remove the overstorey without damaging the underplanted trees much at all, although it did require a lot of careful planning. So this slide is just a point data 3D image of the experiment area in June 2023. So this was produced by Dowie Roebuck from NRW. And this was the site 7 years after the overstorey was removed. And I'm really just showing this just so you can sort of see the rectangular area where the experiment was, where the overstorey has been removed. And you can see that it's now pretty well stocked with these underplanted seedlings. And you can also see really where the permanent rack structure still exists. So just moving on to a few conclusions really then. Regarding microclimate benefits, we did find that under canopy microclimate was generally more benign, and that this can be protective for sensitive species during establishment. So the photo here is just of a coast redwood on an open site with quite severe frost damage. And it's really just to sort of suggest that underplanting might be a good thing to consider in locations which are going to be more testing for seedlings. So perhaps sites which are known to be drought prone or frost prone. And there is, of course, a growth trade-off in the low light conditions. So success is much more likely where the canopy density is kept quite low. And of course, it's the usual message of regular thinning is important. So a few conclusions regarding Douglas fir specifically. It didn't really respond very well to the overstorey removal. And Douglas fir is only categorised as intermediate in terms of shade tolerance. So we think it was really quite close to its shade tolerance limits in this experiment, where the basal area was between 25 and 30 metres squared per hectare during the establishment period. So we're thinking that if Douglas fir is going to be underplanted below Sitka, then the basal area of the Sitka does need to be a bit lower. Or you could probably plant Douglas fir under species which cast less shade, so pines or larches perhaps. But we're also suggesting that Douglas fir might be suitable for group planting situations, and that might suit it better so that it can have some side protection from the surrounding overstorey, but more overhead light availability to suit its slightly lower shade tolerance. So regarding species diversification then, we have identified some shade tolerant species which could be underplanted to diversify Sitka spruce stands. And although some of those species do establish really quite slowly, they seem to catch up before too long. And in general, they responded pretty well to overstorey removal. So we're fairly sure that they were not in check. And the conclusion of that really is that underplanting is, in our view, a good approach for diversifying shade-tolerant species. And it's likely to become increasingly important in changing climates, especially as conditions on open restock sites become more testing. So underplanting might allow establishment of sensitive species which could struggle on these much more open, exposed sites. So just for those who would like a bit more information, there is a publication which includes the full details of the Clocaenog experiment and also the microclimate monitoring project, and that's available on the forestry website through open access. And there's a QJF paper in the April 2021 edition, which summarises the wider experience from the Clocaenog trial as well. So just to finish off, I just wanted to acknowledge help from various people. The work at the site has been the result of a long collaboration between NRW, Bangor University and Forest Research. So Anna Pomeranian designed the experiment and established it, and John Trimble carried out all of the root excavation work. The Forest Research Technical Services Unit carried out all of the other assessments and the data that I've shown. And I particularly wanted to thank Dave Williams for his management of the site over a very long period, and Aidan Cook, who's taken on Dave's role, and their other colleagues from NRW for their long management of the site over the past 20 years or so. And thank you for listening. I'm very happy to take any questions.
Great, thank you very much, Tor. We've had a number of questions of various themes. I'm trying to pick the most appropriate one to start with. So there's a variety. I think I'll just start. I'll start where my eye falls, if that's all right. One question from Joe de Groot was, could the root balling that you picked up and, the problem with the Douglas fir, how sure are you that whether that's planter error or the quality of the plants, or whether it was because of something to do with the underplanting and the overstorey?
Yeah, no, that's a fair question. It's possible that it could be related to the planting. The planting was all carried out at the same time by the same groups of people, and we haven't seen those problems in any of the other species. We haven't actually excavated many of the others. We've excavated just a few trees from the other species and didn't see any particular issues there. So we think it probably is something specific to Douglas fir rather than to wider planting practices. But it was an undergraduate project which was sort of relatively limited in its scope. It takes an awfully long time to dig out trees without losing their root matter. So it's definitely something that we'd like to look at in a bit more detail. But yes, it is possible that there is some planting issue, but it would be hard to see how that wouldn't have affected the other species as well.
Yes, okay. I guess Douglas fir might be harder. It has a reputation for being harder to establish well, doesn't it? And that socketing is a feature, perhaps. I think I've got two questions from Laura Harris. And I think it was Ian Hanna asking about deer. I realize that's not what you're researching, and there are, I guess, either no or very few deer at Clocaenog, but would you like to talk about that? It's going to be an issue for so many of our participants.
Yeah, I think that's a really important point. The deer populations at Clocaenog are relatively low, and we didn't really see any evidence of browsing damage when we were doing the annual assessments. It is, of course, really important for underplanting and also for management of natural regeneration. So yes, I think, you know, it's all too common to hear of underplanting, which has then been browsed very heavily by deer afterwards. So it's, yeah, very important to know that you've got good control of deer, or that there's, you know, fenced exclosure before going ahead with underplanting. So yeah, really important point, I think.
I noticed it was Liam who asked about deer as well. I hope I've done justice to that. A few practical questions. So Toby, Austin, and Will Huckabee, both asking about well, the distance between the distance in meters between machine access racks, and you know, how much of the productive area was lost. You know, are these relatively permanent racks in your view in this sort of system?
Yes, I think they are relatively permanent racks. I'm afraid I haven't got the figures to hand in terms of the actual spacing and distances. One of the sort of benefits at Clocaenog is that, you know, whatever you plant will fairly rapidly be swamped in natural regeneration. So although the planting didn't go right up to the extraction rack edge, and there was a small buffer left for the sort of material handling and timber stacking, you know, that area is very likely, well, in fact, it has already filled in with natural regeneration. That may or may not be desirable depending on what the overstorey species was, and what the management objectives are. But it's yeah, it's a sort of potential way for that area to be filled in, at least temporarily. But yes, I mean, there will be a small sort of loss of productive area just over having that access system in place.
I've got a follow-up. I might invite Martin Price to turn his microphone on. I know you looked at this some time ago, at least, Martin, about the percentage of productive area and so on. Are you there, Martin?
Hi there, Alex. How are you? How are you doing there? Yeah, no, hi, Tor. Great talk.
Hi, Martin.
I think this kind of comes back. I mean, I wrote an article on the Behesta Bill a few years back, and it kind of centers around how we manage these light thinnings operationally, and it's got the sort of the you know, I know they've got the turn-in stoned areas at Clocaenog, and you know, that kind of quarrying has got a cash cost. It's also got quite a heavy carbon cost. But as the sort of observation, if we're having to pull brash in, presumably from clearfells, you know, this isn't as a system standing operationally on its own feet. And it's just a gentle nudge for you to speculate wildly on how we might go about sorting this out. You know, is this a machinery issue, do you think? Or, you know, particularly with Douglas fir, if you're saying perhaps we need a bit more light, perhaps we can go heavier. I mean, I know that's kind of dams dependent and climate dependent. I'll leave it to you. Go on, speculate.
Yeah, well, I think I would be speculating outside my area of expertise there, Martin, sort of straying into operational processes. But yeah, I mean, it is a fair point that, you know, within Clocaenog, they have, you know, the sort of great luxury of having natural regeneration to spare. Basically, it comes up like cress everywhere. So, you know, I think what they've often done is used roadside clearance material, and then sort of laid that into the racks. Yeah, so I think I'll probably leave my response there, and I don't know if there's anyone else who's got more operational experience than me in terms of the sort of rack and operational systems.
So, I mean, to pick up the Douglas fir, do you think maybe going heavier quicker? I mean, I know we've looked at the planting quality, but perhaps just going heavier quicker might be the way forward.
Yeah, I think it could be. Yeah, it's something that I think we need to do some trials on, research trials and, you know, operational trials as well, just to sort of see how these things work out and on different site types.
In the spirit of inviting people to join in, I don't know whether Will, have we done justice to your question on this as well? Will Huckabee, feel free to switch on.
Trying to work out how to do that. Yeah, no, that was helpful. I mean, it's just looking at the sort of sketches for the system. It was how much productive area you would lose. Obviously, if you've got permanent racks, I suppose with softer soils, similar to what Martin was saying, your ability to have permanent racks or suitable brash cover again might be limited if you know your productive area is limited. So and I suppose the other thing I would make is the amount of light and the regen, definitely from my experience, is potentially a negative, the costs of managing that. So yeah, trying to keep light levels down in areas where so you're not having to clear that would be an observation. But no, thank you very much. That was really helpful.
Thanks.
Thanks, Will. A number of questions from Ian Hanna. So I think I'm going to invite you to pick one, Ian, that you particularly like to put to Tor. Are you there? And happy to switch on, Ian Hanna. Sorry, I'm putting people on the spot here. I hope that's okay. One related, relevant question there was about well, soil compaction from the actual operations. So just finishing off perhaps on that. Ian asked about
that. About whether there was any soil compaction,
yes,
or how to
delayed
manage it.
and delayed impact that might have come from post thinning soil compaction.
Yeah, possibly. I mean, I think the sort of ethos that they've tried to stick with as much as possible at Clocaenog is spending as little time as possible off the rack. So they've really sort of tried to sort of put this permanent rack system in, which they rarely stray off, certainly in the sort of later stages of the crown thinnings and the final overstorey removal. So hopefully over time that should sort of help to reduce that. And I mean, as Martin mentioned earlier, they have sort of invested in sort of stoning the sort of ends of the racks, which is quite an expensive and costly approach, but was something they were able to do at Clocaenog, but might not be possible everywhere.
I've got a question from Liam that strikes me. Was any hylobius control required, or is the truth in the idea that we can avoid hylobius control by managing regenerating stands under a canopy?
Yeah, well, no hylobius control was required there. No. So yes, potentially that's a sort of positive for the CCF approach. I haven't actually looked at the figures. I don't think there was any records of hylobius damage in the early years. So I mean, I expect you'd sort of expect that in the sort of first year or two after planting, at which point that was when it was managed by the university and Arna Pomeranian. But I'm not sure that they did any actual assessment of hylobius damage. But it doesn't seem to have been commented on elsewhere, and it certainly hasn't been severe. So it's a potential benefit there.
I'm looking at further questions. I hope I'm doing justice to this, to the participants. So I've got two questions really about the relatively open canopy, let's say, and I might add one of my own. So Laura Harris was asking, was the canopy so open that there was some competition from grass, for instance? Obviously you had a lot of Sitka regeneration that you mentioned.
Yeah, we didn't really have any competition from grasses. No, I mean there was perhaps a small amount, but it wasn't really significant. No, the main competition was from the Sitka regen, which we did clear with glyphosate, which of course will have cleared the grasses as well at the time. But yeah, it was it's not a very rich site, so that will have been in our favour, I guess.
Right. Thank you. Nick Hill was spotted the root, the leader and side shoot proportions with Douglas fir. Again, is it relatively light? Did you measure light, in fact? It leads me to another question of my own, really, which is that looking at the graphs, all the species appear to be doing quite well, and we might think that some of them are more shade tolerant. Is it the case that because of the silvicultural system, there was perhaps more light than there might be in other situations, and all of these relatively shade tolerant species did okay?
Yeah, perhaps. I mean, we did have to work quite hard to keep the basal area down to its target was 25 meters square per hectare, and we did have to go in fairly frequently to thin that. I think we had a 3-year and then a 4-year thinning cycle to actually keep it down. So it was going up again very quickly. I think right from the early, sort of the starting position of the trial when it was set up in, or the wider trial set up in 2001, the overstorey had always been quite well thinned, I think, at Clocaenog, and it was anecdotally planted as a mixture with Scots pine in some areas too. So there will have been an element of self-thinning too. So yes, I think it's you know, the light levels were relatively high, I think, compared to some underplanting situations. But that required quite a bit of work and regular interventions to get to that point.
I realize I've got a few questions here that sort of may go beyond. So questions about, well, Alex Gillum asked whether there were any broadleaf mixtures, and somebody else asked about beech, whether there's other research going on, perhaps. So again, Ian Hannah asked about beech. And also in terms of the underplanting, I hope, sorry, I'm trying to make sure I'm naming folk. So one question was from Benjamin Turner, whether the Sitka underplanting was improved Sitka, or what was its origin, perhaps. So a bunch of questions there about species and so on. And I'm wondering about things like Western red cedar and so on. But perhaps we're unfairly pushing you beyond what your actual research was. So over to you.
I'll try and go through some of those before I forget them. Firstly, on beech and broadleaf mixtures, there hasn't been any broadleaf mixture work at Clocaenog in this experiment. Elsewhere within forest research, we are doing some work on other mixtures, both other conifer mixtures and also on conifer broadleaf mixtures. And my colleague Andrew Leslie, he's starting to look at some of those in more detail too now. So he's going to be doing some work on that in the near future. Mm-hmm. The Sitka was veg prop Sitka, which initially performed really quite poorly compared to all the naturally regenerated Sitka. And that was, quite interesting. I mean, anecdotally, there's always been this sort of idea that natural regeneration is much more vigorous and has better root systems than planted trees and nursery trees. And actually it really did seem to be so. So that, the planted Sitka did not perform particularly well at first, although once it got going, it was fine. And it's really starting to grow a lot faster than the other species on the site now.
And we've got one question on the provenance of the Douglas fir as well. Would that have been relevant? That's John Burgess. Thank you, John. I
think it probably is relevant. Unfortunately, we don't have the records of what it was. So this is one of the joys of slightly longer term research, isn't it? That we've had a great collaboration with Bangor and with FC Wales, or NLW now, but we weren't, forest research wasn't actually involved in the early stages of the planting of this experiment, and we don't actually have the records for provenance, unfortunately. But yes, I expect it is relevant. So that's something else that we're hoping to be looking at in the near future, is a bit more work on Douglas fir and provenance.
Great, thanks. I have a contribution perhaps from Laura Harris saying that Wiltshire and Maynooth University are looking at beech, Douglas fir and red cedar under Sitka as well. So maybe we've got someone to invite to speak to us about that. A couple of people have asked about mycorrhizal fungi. So Ian Hannah, I think, and Josh Diplock have asked. I'm not sure whether Josh, would you like to speak? I want to do justice to the question. Perhaps I'll just read it then. Could mycorrhizal fungi already present in the soil associate better with the other trial species compared to the Douglas fir? And could that explain why the Sitka spruce performed best?
It could do, yes, it's possible. I'm afraid I don't know much about that really, and we didn't actually do any mycorrhizal work on the site. But yeah, I think that's a possibility, and there is, of course, an increased interest in mycorrhiza at the moment, and quite a lot of research starting on that. Some of my colleagues in forest research, Nadia Barsoum, she's doing some work on mycorrhiza in mixtures at the moment. So she's going to be sort of looking at that a bit as well, and also looking at interactions between ectomyzal and arbuscular mycorrhizal systems as well. So yeah, it's something that with hindsight, it would have been really good to have a look at the experiment site, but I think we missed that.
I think I hope everybody recognise, experiments can't look at everything. So
yeah, resources are limited. So.
We're getting to the end. We'd like to try and finish promptly with these. I'm just wondering if there's any question I've particularly missed. I do apologize if I haven't done justice to all your questions. So I'm thinking I have. There was a question about red squirrels and pine martens, but I'm guessing that is also perhaps out of what you've been looking at. So I'm sorry, as Brian Palmer, I think we may be not able to answer that one. This final one, perhaps this is relevant. I think probably a lot of us will be thinking, we're interested in more continuous cover, let's call it, than an even-aged overstorey system. I wonder if the Douglas fir might have done better in a forest environment for longer, perhaps.
Yeah, possibly. Yeah. I mean, certainly the Douglas fir, prior to the overstorey removal, we were kind of quite pleased with the Douglas fir, and we thought it was going pretty well. And it was only after the overstorey removal and the very wet winter that we started to notice the problems with it. So yes, potentially if we'd kept the overstorey for longer, or even sort of kept a permanent tree presence on the site, then the Douglas fir may well have come through the sort of relatively light demanding stage of its early establishment, and then developed its root systems and increased diameter at that point and been fine. So yeah, we don't really know, but potentially it could have persisted for a lot longer, and perhaps started growing a lot faster once it was if it was kept in the shade and hadn't had that sort of sudden exposure, which it didn't seem to tolerate very well at all.
Yes, well, thank you for that. Perhaps that's a good point to end. Somebody thanking you online as well for all the insights you've given us about how the Douglas fir reacted, which is interesting. I think I'll say we've reached 5 o'clock. So thank you to you, Tor, very much. These seminars, have gone very well for us, really. We're CCFG's, pleased with the way they've gone. And thank you to all the participants who are here today as well. So thanks to all of you for being here. And thank you again, Tor.
Great. Thank you all for coming. Great.